This is the final video on habits. I want to mention again pausing. I mentioned it in the last video. You should be pausing this video and any future video whenever you feel like it. In fact, all these problems, I encourage you to attempt them before I go into them. Okay, so pausing is really, repeating pausing is very crucial. Notebooks and pencils. I highly encourage you to have a notebook. I prefer that to a stack of paper because papers get lost. Notebooks are a lot more organized. So a notebook and a pen or pencil, and take notes on any of this stuff. Don't feel like you have to take notes on everything. If that's the way you like to learn, do that. This should be helping you. So if this is not helping you, then make it help you. All right, let's get into telescoping. So we've been talking about several habits. Now we haven't covered every single math habit there is because there are too many. I wanted to give you guys a sampler of some important math habits so that you could see the effect that it has on math. Now telescoping is not one of the more critical skills. It's kind of a fancier thing, a little more advanced. It's pretty nice, and the reason I'm putting it in here is that I want to stress that math is not just about function, it's also about doing beautiful things. And so this is just an example of something that shows that math is an art and a meditation and not just this rigid thing that robots do. So math is very much an art and a meditation, and the further you advance in your math education, the more you'll see that. In the beginning it may look like we're just drilling things and it's little basic skills, but later on the problems get a lot more creative and they become more fun. Alright, so these three examples are all going to be examples of telescoping. What is a telescope? I'm sure all of you know. So the idea, what we need for our purposes is that a telescope is like this, and that it can contract. So it can expand and contract in sections. Alright, so a lot of these problems look pretty scary. Now remember, this is not to do on a calculator or to do however you want. These are meant to be very nice problems. So if you see a nice way of doing these become very simple. If you don't, they're not simple. So let's do number one in two different ways. So the first method is the obvious method, is to say 2 minus 1 is 1, 3 minus 2 is 1, 4 minus 3 is 1. So each of these is going to be 1. So how many ones do we have? Well, if we focus on the second number, 1, 2, 3, we're going to go all the way through 99. The dot 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 means keep going in this fashion. So therefore we're going to have 99 ones. So this should work out to be 99. Now that's one method. That's not the telescoping method. I want to show you the telescoping method. So the telescoping method is to notice that the 2 and the minus 2 cancel each other off. Now let's go to the 3 and the minus 3. They'll cancel each other off. And in fact, if we keep going, everything will cancel each other off, almost everything. Right, so 98 and negative 98 are gone. 99 and negative 99. So if we do this, almost everything will be erased except for this first minus 1 or negative 1 and this 100. So 100 minus 1 also gets us 99. So that's the telescoping method of doing number one. All right, let's go to number two. Number two is a little harder than number one, and if we try thinking of it this way, we really don't know what to do other than just to multiply. So here's the little hint. Let's convert all of these to improper fractions. So what is 1 1/2? That's 3 over 2. What's 1 1/3? That's 4 over 3. What's 1 1/4? That's 5 over 4. So hopefully a lot of you are already seeing this. If not, when we multiply all of this, these will cancel. So in fact, everything will cancel diagonally. So this will be 11 over 10. This would be 10 over 9. So these will be gone. So let's rewrite everything as improper fractions. So everything will cancel diagonally except for the corners, which are 11 and 2. So your answer is 11 over 2. So why is this telescoping again? Because we had something long, and by doing something a little clever to it, we've managed to shrink it down. So it contracted like a telescope, but it used to be expanded. All right, let's go to number 3, which is fairly tricky if you've never seen this. All right. Now again, we know we're looking for something that involves telescoping here, but these are all pluses, they're not multiplication, so we're not really sure what to do. So here's the big idea for this problem. Let's look at 1/6, which is 1 over 2 times 3. And the key idea is that we can also write it this way. What's the benefit of this? Instead of doing a multiplication, we have a 2 and 3 involved, but with a subtraction. So why is that good? Anytime you start to get pluses and minuses, you might start to introduce telescoping. So now this becomes plus. Now already this should start to look like number 1 a little bit. So look at this negative 1/3 and positive 1/3, they're gone. In fact, everything is going to start to cancel off. The negative 1/4 will cancel with the 1/4 that's to come. So everything is going to be gone other than this first half and that negative 1 over 100. And we can combine this, so this would be 50 over 100 if we give it a common denominator, minus 1 over 100. And so your answer should be 49 over 100. And this was a little more advanced, but this is just to show you some other beautiful ideas such as telescoping. And the more math you get exposed to and the more you stick around for the next few videos, we'll see a lot of other cool ideas floating around. All right, I'll see you guys in the next video.